In the last lecture, I told you the different laws of transverse vibration in a setting. And we'll do some question related to case study. Data is given, okay, and then questions are put on that data. For example, the fundamental frequency with which string is made to oscillate, the formula is n is equal to 1 over 2L E by M under root. This is fundamental node, is the minimum frequency with which a string is made to vibrate. Okay. L is the length of the string. Ends are fixed. Nodes at the ends and antinode in the middle. This is a case of standing wave. Standing wave, the equation is given by 2a cos 2 pi by lambda into x into sine of omega t. Okay. This is the resultant wave. This is the expression for standing wave. Standing wave is a special case of superposition of waves in which two identical waves having same frequency, same wavelength, traveling from opposite direction, okay, coming simultaneously and independently, they reach at a point in the space at the same time, then there is a redistribution of energy and the result is the formation of node and antinode. So node is a point where displacement is zero, pressure is maximum and particle of the medium is not free to oscillate. Then antinode is a point, is a, you can say the section of the medium where pressure is minimum, displacement or amplitude is maximum and particles are free to oscillate. So we talk about nodes and antinodes in the case of standing wave formation. Okay, standing wave is a special case of superposition of wave. Requirement for formation of standing wave, two identical wave approaching each other, coming from different direction. Okay, then you get a resultant wave, and here the amplitude of resultant wave is this. Here this string is made to vibrate in one segment and it will vibrate with this frequency which is called fundamental frequency. And if the same string is made to oscillate in 2 segments or 3 segments, then the frequency will be higher than the fundamental frequency. It may be double the fundamental, it may be 3 times the fundamental. So yesterday I told you that different overtones also, the overtones they are higher note. Higher note means higher frequency. I told you that when the singer is given a song and he is singing, and then the singer has to see in which note a particular part of the song is to be sung. It is the starting of the song, or middle of the song, or the end of the song. Okay, so in which note the singer is to sing the song. It is to increase the frequency, means is to sing in the higher note. आवाज को थोड़ा हाई फ्रीक्वेंसी में लाना है या फ्रीक्वेंसी लो करनी है, ये फंडामेंटल फ्रीक्वेंसी है, इसको फर्स्ट हार्मोनिक भी करते हैं, ये नोट है, ये मिनिमम फ्रीक्वेंसी. Okay, you cannot make this string vibrate as a whole in one segment with a frequency less than this. This is the least, this is the fundamental. And if this thing is made to vibrate in 2 segments, then what will happen? Here node in between another node, then antinode. Length is same, and here the frequency will be 2 times the fundamental, because this length will be equal to lambda, whereas in this case length was equal to lambda by 2. Remember, both the ends of the string are fixed. You can make this string vibrate keeping one end fixed, second end free. There are different ways. But here ends are fixed, but string is made to vibrate in two segments. Then this frequency becomes double the fundamental, double than this. This frequency is called first overtone, and this is second harmonic. Okay, and in other words, we will say this is a higher note. This higher note has frequency double the frequency of the fundamental. Clear? Yesterday I told you, if same string is made to vibrate in three segments, then frequency will become 3 times the fundamental. The common formula for that was NP is equal to P over 2L E by M under root. This was Pth harmonic. P was the number of segments, number of loops. Here P is 1, here P is 2. Okay? Number of segment here 2, here number of segment 1. So P is the number of segment and B is the frequency with which string is made to oscillate. Length of the string is L, E is the tension, M is mass per unit length. Okay? Then I gave you the laws. What was the laws? There were 5 laws, 3 main laws and 2 sub-laws. The laws were: number 1, law of length. Fundamental frequency inversely proportional to length. It means N1 L1 is equal to N2 L2. It's law of length. Then second law was law of tension. Fundamental frequency is directly proportional to square root of tension. It will mean N2 by N1 will be T2 by T1 under root. Okay? The third was law of linear mass density. Fundamental frequency inversely proportional to square root of linear mass density. N2 by N1 will be M2 by M1, M1 by M2 under root. Clear? These were the 3 main laws. Then there were 2 sub-laws. How fundamental frequency is related to the diameter of the wire and the density of the material of the wire. तो उसके लिए हमने क्या किया था? mass of this wire, area of cross section into length into density. This is the mass, capital M. We want small m, which is mass per unit length. That is pi d square by 4 into L. On putting this value of m here in this relation, you get m is equal to 1 over L d under root T over pi d, which means fundamental frequency inversely proportional to diameter, fundamental frequency inversely proportional to square root of the density of the material. Okay, so I have given you this case. Case is regarding transverse vibration in a string and the laws of transverse vibration in a string. Okay, I told you the fundamental frequency. This is called note. Which note? This is first harmonic. Okay, and when it is made to oscillate in two segments, then this is second note, higher note. This will be called higher note. Higher note means frequency is more than the fundamental. You know how this is related to this? In this case especially, when it is made to oscillate in two segments, the higher note has frequency double the fundamental frequency. Got my point? So in case study questions, some case, the case may be related to particular concept. Here the concept is laws of transverse vibration in a string. There are three main laws and two sub laws. This is the case. You know, based upon this case study, you will answer some question. Got my point? For example, first question will be the string in a musical instrument, maybe piano, maybe electric guitar, or any instrument in which string is used to produce vibration and sound. Okay, you know certain musical instruments in which string is used to produce some sound, and that sound may be note, fundamental note, that can be higher note. Higher note means overtones. This first add-on is this add-on, which has frequency double the fundamental. This is first overtone or second harmonic. Second harmonic means higher note. Which higher note? Second higher note. And if this same string is made to vibrate in three segments, number of segments 3, the frequency will be 3 times the fundamental. P is equal to 3. This is pth harmonic. Pth harmonic means P minus 1th overtone. Second harmonic means first overtone. So this is pth harmonic and P minus 1th overtone. Okay, and all these overtones are called higher and higher note. Higher and higher note. If you want to make the sound while singing, you want to make the sound shrill, you have to sing in a higher note. You have to increase the frequency. When person sings, sound is produced. The cause of sound production is vibration. We have here, you have studied in class 8th also. We have vocal cord over here. Windpipe is there. Okay, when we speak, that means when we speak, result is sound. And the production of sound is vibration. In the windpipe, air is made to vibrate. Vocal cord is there. ठीक है ना? तो इसको हम कोई गाना गाते हैं तो कैसे इसको मैनेज करते हैं कि इसको कैसे वाइब्रेट कराना, किस फ्रीक्वेंसी से वाइब्रेट कराना. आपको जुकाम हो गया, खांसी हो गई, गला खराब हो गया, ये थोड़ा हैवी हो जाता है. हैवी बलगम जम गई, अब हैवी हो, फ्रीक्वेंसी कम हो गई. अब आप गाना गाएंगे तो लोअर नोट हो जाएगा. अब हायर नोट में आप जा नहीं पाएंगे क्योंकि गला आवाज़ फटने लग जाएगी. गला अच्छी खाओ, मिश्री खाओ, गला साफ हो जाए, फिर यू कैन गो इन द हायर नोट. आवाज़ को बदली कर सकते हैं, है ना. अब आप इसके ना, ये देश है वीर जवानों का, अलबेलों का, मुस्तानों का, इस देश की यारो, इस देश की यारो. ठीक है ना. अब लाउडनेस भी बढ़ानी है, फ्रीक्वेंसी भी हायर नोट में आपको गाना है. जो भी इसको गाएगा, जिसने इसको गाया होगा, ठीक है ना, और बढ़िया गाया होगा, लोगों ने अप्रिशिएट किया होगा, तो उसको पता है कि मुझे कहाँ हायर नोट में गाना है, कहाँ फ्रीक्वेंसी कम करनी, कहाँ हाई करनी है. गॉट माय पॉइंट. तो यहाँ आपके पास हायर नोट भी है. हायर नोट मीन्स ओवरटोन्स हैं, और आपके पास फंडामेंटल नोट भी है, लोएस्ट फ्रीक्वेंसी भी. लोएस्ट फ्रीक्वेंसी when the string is made to vibrate in one segment. When it is made to vibrate in 2 segments, keeping other factors same, frequency becomes double the fundamental. This is called higher tone, higher note. It is first overtone, second harmony. Okay, so this is a expression which will give you the frequency of pth harmony. When this thing is made to vibrate in P segment, here there are 2 segments, P value of P is 2. Here P is 1. And you can make it vibrate in 3 segments, P will be 3, and this will give you third harmonic, and third harmonic will be 3 times the fundamental, and third harmonic is higher note. Okay, and it is second overtone. Every overtone is higher note. Every overtone has frequency greater than the fundamental. Okay, so these are the laws which govern the transverse of vibration in a string. The instrument I told you yesterday, sonometer. Sonometer, there is a wire. There was one back on one side where wire was fixed. And then 2 wedges were there. Then the free end passes over the pulley. Then there was a hanger, and then you put slotted weight to produce tension. Okay, now it is up to you to make the wire vibrate in 1 segment or 2 segments. If you want to make it vibrate in 1 segment, then you will get this frequency. And sonometer is an instrument by which you can verify all the laws. Now we have this case and then case study question. My first question is, string in a musical instrument. A string in a musical instrument is 50 centimeter long. A string in a musical instrument is 50 centimeter long, and fundamental frequency is 800 hertz. What is the required length? What is the required length if the string is made to oscillate with a frequency 1000 hertz? There will be 4 choices, A, B, C and D, and you have to select the right option. Now first of all you have to see that this is a case related to the transverse vibration in a string, number 1. Okay, number 2, this question is based upon the law of length. He has talked about length only, length and frequency. ये 2 चीजें नहीं है. The length was 50 centimeter, frequency was 800 hertz. What is the new length? If wire is to vibrate with a frequency of 1000 hertz. Okay, problem is based upon law of length. Law of length is this: N1, L1, N is inversely proportional to length. Okay, so for length L1, frequency is N1, for length L2, frequency is N2. Result now is this. Now you are given N1 800 hertz, L1 50 centimeter. You want N2. You have N2 1000 hertz. Make use of this law of length and get the answer. And select the right choice. Okay? Let us say answer may be 40 centimeter, 30 centimeter, 37.5 centimeter, 62.5 centimeter. So if you apply, this question is based on law of length. So N1 is 800, L1 is 50, N2 is 1000, and L2 is to be calculated. Okay? So from this 800 into 50 divided by 1000, on simplification, you will get L2 is equal to 40 centimeter. The right choice is A choice. Four choices are given. Okay, and case is given. And case is based upon a particular concept. Got my point? And this case is regarding laws of transverse vibration in a string. Basically, it is a case of superposition of two waves coming from opposite direction. Waves were identical. They were traveling simultaneously, independently. They reach at a point in the space at the same time. Then there is a redistribution of energy, and the result is formation of node and antinode. Node is ends of the string. This string is fixed at two ends. Got my point? And it is made to oscillate. The minimum frequency is this. An expression for the new wave is this. Okay. So this question is not based upon this, it is based upon this. Law of length. Got my point? Now, another question. There is a progressive wave, though it is a expression for standing wave. Standing wave is the result of two progressive waves coming from opposite direction. दो वेव opposite direction से आती थी, progressive wave होती थी और बाय चांस सुपरइम्पोज करती थी. वेव आइडेंटिकल होती थी, डायरेक्शन ऑपोजिट होती थी और सेम टाइम पे सेम पॉइंट पे पहुंच जाती थी. नोड एंटीनोड रिजल्ट होता था. ओके, अब नोड बनेगा कि एंटीनोड बनेगा. नोड का मतलब ये जो डिस्प्लेसमेंट है जीरो है. जैसे यहाँ डिस्प्लेसमेंट जीरो है इसलिए इसको नोड बोलते हैं. यहाँ डिस्प्लेसमेंट मैक्सिमम है, जहाँ डिस्प्लेसमेंट मैक्सिमम है उसको एंटी नोड बोलेंगे. ओके, तो कहाँ डिस्प्लेसमेंट जीरो है? यहाँ. यहाँ आपको बताया एक्स इज इक्वल टू जीरो है. यहाँ डिस्प्लेसमेंट, यहाँ से वेव चली है. एक्स इज द डिस्टेंस ट्रैवल्ड बाय द प्रोग्रेसिव वेव. वाई इज द डिस्प्लेसमेंट ऑफ द पार्टिकल which is executing simple harmonic motion and is taking part in the propagation of wave. X and Y, they are different. Okay, so here X is 0, here at this end X is equal to L, Y is 0. Y is 0. Very good. Why? Because it is node, displacement is 0, and at any point where displacement is 0, that point is called node. Why displacement 0? Pressure is maximum. Okay? So, if you take the middle point where there is an antinode, displacement is maximum. Displacement of the new wave, displacement of standing wave is given by this. It will be maximum when sin omega t is 1.
Yes, sir.
Cos is 1. This will depend upon cosine factor and sine factor. I am talking about only the amplitude, where amplitude is maximum. This is amplitude, this part. So my question will be related to amplitude, not on this factor. Amplitude maximum. So amplitude is given by this. And where or when this will be maximum? When cos factor is 1. Because cos has maximally 1. जब cos maximum हो जाएगा, displacement maximum हो जाएगी. अब कितनी होगी? 2a. यहाँ displacement कितनी है? 2a. यहाँ y is equal to 2a. What was a? A was the amplitude of progressive wave, which took part in the formation of standing wave. Two waves were required. Both were progressive. Both were identical. Both were having same frequency, same value, but they were coming from opposite direction. then result is node and antinode formation. Node means displacement 0, antinode means displacement maximum. 0 displacement means y is 0. Maximum displacement y is equal to 2a. Maximum displacement. Okay? Now certain physical quantities, certain parameters, certain properties are related with progressive wave. So my second question is, the progressive wave is traveling in a medium progressive wave is traveling in a medium okay. The properties or the physical parameters related with the progressive wave is number 1 velocity, number 2 wavelength, number 3 frequency, my question is, progressive wave is traveling in a medium. We see the expression for the progressive wave which is traveling along positive x direction with a velocity omega by k. Okay, the amplitude A at time t, the particle has a displacement y and wave has traveled a distance x and it is going along positive x direction. Now it is associated with velocity, wavelength, frequency, and third choice I will give you. You have to tell which quantity doesn't depend upon other factor. The fourth choice will be all above parameters are dependent. Means all depend upon each other. Fourth choice. The question is, which quantity out of these? एम्पलीट्यूड तो लिया ही नहीं, क्वेश्चन तो सुनने दे। एम्पलीट्यूड तो
तीन बार बोल चुके हैं भाई, कहाँ तक देखो।
एम्पलीट्यूड चॉइस में नहीं है। Okay, in the given choices, amplitude what is not there. The question will not be related to amplitude. You want to tell out of these which quantity is independent of other, which quantity doesn't depend upon other. Okay, and you know these three, they are related to each other by this relation. V is equal to L lambda. Wave velocity, wavelength, frequency of the wave, they are related to each other by this relation. Then even out of these three, there is one quantity which doesn't depend upon other. What is that? That is the question. And that is given among these four choices.
all above parameter dependent है वैसे फिर तो
All are dependent on each other. No.
सर जो ये तीन ऑप्शन
बोला कि इन तीनों में से भी है कोई एक।
Yes, there is only one physical quantity out of this which doesn't depend upon other. Other means, if you take this, do you think it is independent of this and this or this?
सर ये साइन ए साइन मतलब नॉट टू सर velocity
No.
velocity
Velocity is dependent upon wavelength. This is the quantity frequency which doesn't depend upon velocity. It doesn't depend upon wavelength. Frequency is the only parameter in a progressive wave which is independent of other parameter. If wavelength changes, velocity will change. Okay? But frequency will remain unchanged. wave may move in one medium, it may enter the second medium. You know, when wave goes from one medium to another, from rarer to denser or from denser to rarer,
Yes.
there is no change in frequency. In a denser medium, speed of wave will decrease. Okay? And when the speed will decrease, it is related to wavelength because this item is constant. It is independent of V and lambda. So therefore, the fourth choice, all above parameters are dependent? No. Frequency is
Right.
independent. Only frequency is independent of wavelength velocity. Got my point? There was a progressive wave given by this traveling along positive x direction. I told you there is one parameter out of these which is independent of other. Other में वही लेना जो यहाँ दिया है, अपनी तरफ से other में ऐड नहीं करना कुछ. Parameters are velocity of the wave, wavelength of the wave, frequency of the wave. इनमें से कौन है जो डिपेंड नहीं करता बाकियों पे? And if you are saying that all are dependent upon each other, the right choice would have been D. But frequency is the physical quantity which doesn't depend upon other factors. It doesn't depend upon velocity and wavelength. Wave may move in the same medium, wave may get reflection, wave may enter into the new medium, but frequency is the only quantity which will remain same. इसकी से कोई फर्क नहीं. चाहे वेव का रिफ्लेक्शन हो, चाहे वेव का ट्रांसमिशन हो, चाहे वेव सेम मीडियम में जाए, चाहे वेव नए मीडियम में एंटर करें, फ्रीक्वेंसी लेनी चाहिए. Got my point? Third question. Third question. The piano wire, piano string used in piano has a fundamental frequency and if string is made to vibrate with double the fundamental frequency, same thing is made to vibrate with double the fundamental frequency, what will happen to the tension? Again there will be four choices. This question is related to law of tension. Yes, talk about fundamental frequency and the string is made to vibrate in higher tone, double frequency. What will happen to tension? Okay, so only the frequency and tension are to be discussed. That means the question is based on law of tension. Okay, so what is the law of tension? Fundamental frequency directly proportional square root of tension. Or you can say N2 by N1 is equal to T2 by T1 under root. Now here you are given N2 is 2N1. Okay, same string is made to vibrate with double the frequency, double of the fundamental. What will happen to tension? Tension को क्या होगा? तो ये this ratio will be 2 because N2 is twice of N1. This is our requirement. Okay, scaling both sides. T2 will become 4 times. You can say tension same रहेगी, 4 times हो जाएगी, 2 times हो जाएगी. Okay, या आप कह सकते हैं कोई और चॉइस दे दो. क्या हुआ इसमें? tension will T2 will become 4 times T1. Right choice is
40.
4 choices will be given to you.
ठीक, जो चॉइसेस हैं ये केस बेस्ड क्वेश्चंस में ही होंगी.
Yes,
इसमें 4 होंगे ना क्वेश्चन से.
yes.
सेम क्वेश्चन दोबारा समझा दो.
In a piano, the string has a fundamental frequency n, and we want the string should oscillate with double the frequency. What will happen to the tension? अब फ्रीक्वेंसी आप डबल करना चाहते हैं तो टेंशन कितनी करनी पड़ेगी? क्या सेम टेंशन से आप फ्रीक्वेंसी डबल कर सकते हैं? लॉ ऑफ टेंशन है, फ्रीक्वेंसी और टेंशन की बात हुई है. फ्रीक्वेंसी डबल करनी, व्हाट विल हैपन टू टेंशन? व्हाट इज द रिलेशन बिटवीन फ्रीक्वेंसी एंड टेंशन? दैट इज द लॉ ऑफ टेंशन. व्हाट इज दैट? fundamental frequency directly proportional to square root of tension. For tension T1, let us say previously tension was T1, frequency was N. Okay, now frequency is to be made to N. What will be the new tension? To make use of this equation, N2 is double of N1. So this ratio will be 2. When squaring both sides, तो 2 का स्केयर 4 हो जाएगा, इधर T2 by T1 आ जाएगा, स्केयर रूट हट जाएगा, तो T2 will become 4 टाइम T1. जितनी पहले टेंशन थी 4 टाइम करनी पड़ेगी. बोलो. नेक्स्ट क्वेश्चन. नेक्स्ट क्वेश्चन. इन a musical instrument, musical instrument, the length of the string and diameter of the string both are doubled. Both are doubled. The new frequency, again 4 choices. Length and diameter both are doubled. Okay, so length and diameter both are doubled. So you have this summation. Fundamental frequency 1 over L D under root P by pi D. We will make use of law of length and law of diameter. Diameter and length. So you have to find out the formula in which both length and diameter counts. So length and diameter. Okay. When length and diameter were normal, what was the frequency? The length was L, diameter was D, frequency was this. Now length is doubled. That means L is made. Diameter is doubled. Instead of D, it is made 2D. Other factors not affected.
Sir, 2-1.
Anji?
2-1.
This frequency will be this was the previous frequency. Original frequency. Look here. At the first instance, when you are given length and diameter both are doubled. इनकी बात नहीं हुई. Length and diameter both are doubled, and frequency is inversely proportional to length and diameter. जब ये दोनों डबल हो गए तो फ्रीक्वेंसी तो कम होएगी ना, क्योंकि इनवर्स रिलेशन है ना. इनवर्स रिलेशन का क्या मतलब है? एक पैरामीटर अगर आप बढ़ाते हैं तो दूसरा पैरामीटर कम हो जाता है। लेंथ और डायमीटर दोनों डिनोमिनेटर में है, दोनों से इनवर्स रिलेशन है, दोनों आपने डबल कर दिए, दोनों बढ़ा दिए ना, तो फ्रीक्वेंसी बढ़ेगी थोड़ी, प्रीवियस फ्रीक्वेंसी कम ही मिलेगी। 1/4 हो गई। ये वो फ्रीक्वेंसी है when there was no change in length and diameter. Now length is made double, diameter is made double, and he has not talked about tension and density of the material of the wire. सिर्फ यहाँ तक प्रॉब्लम रिस्ट्रिक्ट है। और n is inversely proportional to L, n is inversely proportional to D. Clear? तो new frequency, let us say n dash, new length into L, new diameter 2D, new tension and new density same. And here you will find it new factor 4 in the denominator. बाकी तो सारा वही है, इधर 2 2 4 ये एक्स्ट्रा फैक्टर आ गया, बाकी तो ये फंडामेंटल है। ओके, डिनोमिनेटर में 4 आ गया, then that means frequency will be n/4. It reduces to 1/4 of the reasoning.
Yes, sir.
Case is given, all relations are given, concept is given, okay, and the questions are based upon this case. Now you have to decide that the case has different parts, okay. In this case, fundamental frequency, there are different factors on which this depends: tension, density of the material, diameter of the wire, length of the wire. ओके, तो आपको ये देखना है कि क्वेश्चन में किसकी बात की है। यहाँ सिंगल पैरामीटर की बात की है, लॉ ऑफ लेंथ, लॉ ऑफ टेंशन, लॉ ऑफ मास पर यूनिट लेंथ। इसमें सिंगल पैरामीटर है, यहाँ डबल पैरामीटर है, यहाँ दो की बात करती है साइमल्टेनियसली इन द सेम क्वेश्चन, 2 फैक्टर्स आर अफेक्टेड, बोथ आर मेड डबल। ओके, तो फिर क्या नया फैक्टर आया, आप इनको इसको डिवाइड करो, डिवाइड दिस बाय दिस, तो आपको सिर्फ एक नंबर बचेगा इस रेशियो में, n डैश बाय n 1/4 बचेगा, n previous frequency और n dash new frequency. The new frequency becomes 1/4 of original frequency. Got my point? Next. In a sonometer wire,
Sonometer.
in a sonometer wire, you know sonometer instrument
Yes, sir.
with which you can verify the different laws of transverse vibration in a string. So in a sonometer, the length, tension, are made doubled and the density of the material of the wire is made half. What will happen to its fundamental frequency? What will happen to the fundamental frequency? This is the fundamental frequency. N is equal to 1 by LD T by pi D.
Yes.
Okay, this is the original case. Now in new case, what is happening? Length is made double. Diameter same.
Yes, sir.
Tension is made double. Diameter is made
Half.
half. So make the changes according to the new situation. Got my point? Now see what happens. So n dash here 1 over 2 LD. This 2 will go up. So here you will have 4, take square root, either 4t by pi d, 4 can be taken out by making square root, then 2 will get cancelled, and dash will be 1 over LD, t by pi d. This is the same as this. So 4 choices will be given. ये 2 टाइम हो गया या n/2 हो गया या n/3 हो गया या सेम रहा, या 3 choices and 4 choice, none of the above. Right choice here will be D.
Yes.
Clear? So all these questions, they were related to the case which is given. Formulas are given. Laws are mentioned. And you have to just make use of these laws and these formulas to find the right choice. Got my point? Now we switch over to other part, that is organ pipes. Organ pipes, flutes भी कहते हैं इनको. 2 types of organ pipes. One is closed organ pipe, another is open. Closed organ pipe means one end of the organ pipe is closed, other is open. In open organ pipe, both ends are open. And in both organ pipes, we make air to vibrate, to produce a particular frequency. Let us say we have taken both organ pipes of the same length. Open organ pipe and closed organ pipe are of the same length. Clear? And wherever this end is closed, it will give you load every time. The air in contact with this closed end will be restricted to vibrate. Vibrate नहीं कर पाएगी, टकरा के वापस जाएगी. So this is clearly case of standing wave formation. Nodes and anti-nodes will be talked about. Okay. And the open end where air is free to vibrate, that will become node. And you know, the consecutive node and anti-node, they are separated by a distance. How much?
By the lambda by
Lambda by 4.
5.
This is one wave, and then node anti-node formation. This is one wave, wavelength this, and this is a node. The distance between two consecutive nodes will be lambda by 2. But I am talking about distance between node and anti-node. This distance will be lambda by 4. Clear? So what happens in case of closed organ pipe? At the closed end, node will be found. At the open end, anti-node. And distance between anti-node and node is lambda by 4. And this is equal to the length of the organ pipe. Here is the length of the organ pipe. So lambda by 4 is equal to L, and lambda is equal to 4L. Lambda is 4L. You know this relation, V is equal to N lambda. Frequency will be V by lambda. Here lambda is 4L. The fundamental frequency, first frequency, V by lambda, that means V by 4L. this is the fundamental frequency, the least frequency, minimum frequency, which can be generated in a closed organ pipe. Even in case of closed organ pipe, one end is open, one end is closed. Okay, the closed end will form a node, open end where air is free to vibrate, that will be empty node, and between node and empty node distance is this, and this is the length of the organ pipe. So you express lambda in terms of L, then apply this relation to find out the frequency. It is d by lambda, lambda is 4L, this is the fundamental frequency, lowest frequency, which is called first harmonic. This is first harmonic. Lowest frequency, note, fundamental note. Note means frequency. Higher note, इससे ज़्यादा frequency. Okay, और उससे ज़्यादा और फिर higher note. फ्रीक्वेंसी हाई कर देंगे तो साउंड श्रिल हो जाएगी, तिखी हो जाएगी, पतली हो जाएगी. ठीक है. अब इफ यू कंपेयर द साउंड प्रोड्यूस्ड बाय ए ढोलकी एंड तबला, tabla will give you sound which is shriller, higher frequency sound is produced by tabla as compared to the sound produced by dholaki. Sound produced by cat, sound produced by lion, they are of different frequencies. Okay, sound produced by cat, shrill, high frequency, and roaring of lion, sound produces of low frequency. When you compare it with the sound produced by cat, लड़के की आवाज़ और लड़की की आवाज़, लड़की की आवाज़ श्रिल है, फ्रीक्वेंसी हाई है, लड़की की आवाज़ रफ है, वो फ्रीक्वेंसी लो है. अगर कंपेयर किया जाए, आवाज़ से हम पहचान लेते हैं. ओके, हॉर्न बजते हैं, मारुति गाड़ी का हॉर्न है, ट्रक का हॉर्न है, बिना देखे हम पहचान लेते हैं. बस का हॉर्न है, क्योंकि जो हॉर्न है साउंडिंग बॉडी है, साउंड प्रोड्यूस करेगी, और जो फ्रीक्वेंसी उसने जनरेट करनी है वो नॉन होती है, पहचानी होती है, तो हम पता लग ये बस ने हॉर्न लगाया है, ये साइकिल की घंटी का साउंड है. ठीक है ना. अब आप अपने लीजिए अपने दोस्त के घर में जाते हैं और आवाज़ लगाते हैं, तो आपने या उसने आपको देखा ही नहीं, लेकिन आवाज़ की आवाज़ सुनी और तो प्रतीक आ गया यार, ये तो नहीं आ गया, अरे कैसे पहचान लिया बिना देखे. योर फ्रेंड इज फैमिलियर विद योर साउंड. आपकी साउंड जो है श्रिल है, रफ है, लाउडनेस कितनी है, जब आप बोलते हो धीरे बोलते हो कि लाउडनेस ज़्यादा में बोलते हो, क्वालिटी ऑफ साउंड कैसी है. ओके, उसे साउंड की रिकॉग्नाइज कर लेते हैं. तो ये क्लोज ऑर्गन पाइप है, फंडामेंटल फ्रीक्वेंसी है. अब आप आ जाए तो ओपन ऑर्गन पाइप. Both hands are open. This will be antinode. This will be also the point of antinode. Two antinodes can never come together. They are separated by a node. तो बीच में एक node आएगा. Now this length is equal to, in terms of wavelength, two consecutive antinodes. They are separated by lambda by 2. You can see from here, this is antinode, this is antinode.
Yes, sir.
यहाँ से यहाँ lambda by 2 है. So here L is equal to lambda by 2, and lambda is equal to 2L, and the frequency which is given by V by lambda from this relation. Here lambda is 2L. So here the fundamental frequency in open organ pipe and here in closed organ pipe, how they are related to each other. The minimum frequency in case of closed organ pipe and the minimum frequency in case of open organ pipe, they are not same. Okay? That means in open organ pipe, the fundamental frequency is double the fundamental frequency of closed organ pipe. First observation. fundamental frequency of open organ pipe, which is given by this, is double of this. This is the fundamental frequency produced by closed organ pipe. These two organ pipes, they are of same length, but fundamental frequency of open organ pipe is double the fundamental frequency of closed organ pipe. Clear? अच्छा, by blowing the flute hardly, आप थोड़ा जैसे शंख बजाते हैं तो शुरू में शंख जब थोड़ा जोर कम लगता है फिर आवाज़ भी मोटी आती है, तो जब फिर और जोर लगाते हैं तो हायर फ्रीक्वेंसी की साउंड निकलती है, सिरिल साउंड, बिगुल बजता है ना, ऐसा शंख बजाते हैं तो जब ज़्यादा फास्ट ब्लो करते हैं, ज़्यादा स्ट्रॉन्ग ब्लो करते हैं तो हाई फ्रीक्वेंसी की साउंड प्रोड्यूस होती है। गॉट माय पॉइंट? तो सिमिलरली जो फ्लूट प्लेयर है, जो बंसरी बजाना जानता है, वो अलग अलग सुर निकालता है, उसको पता है ये हायर नोट में कहाँ मिलेगी साउंड। जैसे हारमोनियम, सा रे गा मा पा दा नी, यहाँ पतली आवाज आएगी, सारे गामा पादा नी, फिर सा रिपीट हो गया, फर्स्ट एंड लास्ट ऑक्टेव बन गया, सारे गामा पादा नी सा। 8वें पॉइंट पे फिर वही साउंड निकली, सारे गामा पादा नी सा, लेकिन इन सब में हाई फ्रीक्वेंसी साउंड किसने दी? नी ने, सा ने मोटी आवाज दी। अब किसी ने गाना गाना सारे जहाँ से अच्छा हिंदुस्तान हमारा, तो इसको जब गाएंगे प्रॉपर वे से तो कहाँ हायर नोट और कहाँ लोअर नोट, कहाँ आपको आवाज़ पतली करनी है, कहाँ मोटी करनी है, वो सिंगर ही जानता है। अब जो फ्लूट प्लेयर है वो जानता है। फ्लूट प्लेयर, फ्लूट के अंदर होल्स होते हैं, ओके, तो फिंगर्स से अगर आपने कोई होल बंद कर दिया, वन नोट पैदा कर दिया, दैट पार्ट ऑफ द फ्लूट, दैट पार्ट ऑफ द मीडियम, मीडियम हियर इज एयर, जहाँ आपने क्लोज कर दिया होल को, वहाँ नोट पैदा कर दिया, जहाँ उंगली हटा दी तो आपने यू अलाउ एयर टू वाइब्रेट, एंटी नोट बन गया। तो कितने नोट, कितने एंटी नोट बनते हैं, दैट दे डिसाइड द फ्रीक्वेंसी। ओके, यहाँ एक नोट बना बीच में, अगर आप वेव की शेप बनाना चाहेंगे तो इसकी वेव की शेप कैसे बनेगी? ये वेव यहाँ डिस्प्लेसमेंट मैक्सिमम है, यहाँ 0 है, यहाँ फिर मैक्सिमम है, यहाँ 0 है, ऐसी वेव बनेगी। यहाँ वेव कैसे बनेगी? एम्पलीट्यूड मैक्सिमम है, एंटी नोड पे 0 है, ये वेव है, 1/4 ऑफ द टोटल वेव। So by blowing these two organ pipes harder, you can generate in between open end and close end more and more node, more and more anti node. Here there was only one node in the same fluid where ends are anti node. You can generate instead of one node in organ pipe, open organ pipe, instead of one node you can generate in the same space 2 nodes. Okay, a node and antinode they occur alternatively. पहले अगर एंटीनोड है फिर नोड आएगा, फिर एंटीनोड फिर नोड, दो इकट्ठे नोड में आएंगे, दो इकट्ठे एंटीनोड में। तो अगर ये एंड नोड है तो फिर एंटीनोड है तो ये फिर नोड आएगा, फिर एंटीनोड आएगा, फिर नोड आएगा, फिर एंटीनोड तो आएगा। तो आप कितने नोड बीच में पैदा कर दिए? 2 नोड, 1 एंटीनोड। वेव कैसे बनेगी? डिस्प्लेसमेंट टाइम ग्राफ है ये, यहाँ डिस्प्लेसमेंट 0 है, नोड है, यहाँ भी नोड है, यहाँ भी डिस्प्लेसमेंट 0 है, एंटी नोड पे डिस्प्लेसमेंट मैक्सिमम है। Same open organ pipe of same length, but is blown harder. And in the space there was previously one node, now you have generated 2 nodes. Okay, now you express length of the organ pipe in terms of wavelength. Lambda by 4 is also lambda by 4. This is lambda by 2. तो total length कितनी आ गई? लैम्डा। आधी वेव ये है, 1/4 हाफ ये हो गई, full wave होगी. When you have generated two nodes and one antinode in between the space, in case of upper organ pipe, then length is equal to lambda. So what is frequency? Frequency here will be, ये तो fundamental थी ना, lowest. अब higher tone or first overtone या second harmonic. So N1 will be V by lambda. It is V by L. It is V by L multiply and divide by 2. So here this will be 2 times. This is fundamental.
Yes.
Okay. So in case of open organ pipe, instead of one node, you have generated two nodes, one antinode in the gap between the two open ends. Okay, so the frequency becomes twice the fundamental, double only. Clear? So see what happens in case of closed organ pipe. Same length. This end is node, this is antinode is decided. Okay, now you can generate one node and one antinode. So here L will become by blowing harder.
Yes.
Okay, so you can generate one node and one antinode in between the two ends. So this antinode node separated by lambda by 4. This is also lambda by 4. This is lambda by 4. This is lambda by 4. So here the length will be 3 by 4 lambda, and lambda will be 4 by 3 L, and frequency here will be V by lambda, which means V by lambda. It will give you 3 by 4 L here, and frequency will be 3 times the fundamental. Here fundamental was V by 4 L, now it is 3 times V by 4 L. That means in case of closed organ pipe, the minimum frequency was this. Now the next frequency, next overtone, next note, next higher note, immediately next. That is 3 times the fundamental. Okay. Similarly, you try further how many new node and antinodes can be generated between this space. So you will find in case of closed organ pipe, the frequencies will be 1:3:5:7 like this. In case of open organ pipe, all frequency will be generated. One time, 2 time. Okay, बीच में मिसिंग नहीं है कुछ. लोएस्ट है, फिर उसका डबल है. नेक्स्ट फ्रीक्वेंसी यू कैन फाइंड आउट 3 टाइम होगी फंडामेंटल, नेक्स्ट 4 टाइम फंडामेंटल, नेक्स्ट 5 टाइम फंडामेंटल. All frequency will be there. Okay, and here only odd multiple. 1 time, then 3 times. The next frequency will be 5 times the fundamental. There will be no frequency which is 4 times the fundamental in this case. Next case आपका क्या बनेगा? यहाँ कितने नोड एंटी नोड आप और जनरेट कर सकते हैं in the same length. ये तो डिसाइडेड एंड्स.
Yes, sir.
अब यहाँ एक नोड था,
हाँ जी.
अब आप 2 नोड तैयार करो इसमें. तो एंटी नोड, नोड, फिर एंटी नोड, फिर नोड, फिर एंटी नोड, फिर नोड. सीक्वेंस बन गई ना अल्टरनेटिवली. तो लैम्डा 4 ये है, 2, 3, 4, 5. So length will be 5 by 4 lambda. Frequency will be which is V by lambda will be 5 times V by 4L. So this will give you 5 times fundamental. This is third harmonic, third higher note, or second over note. Yeah, second over note. या ओवरटोन। ये हायर नोट है, हायर फ्रीक्वेंसी मीन्स नेक्स्ट नोट, फंडामेंटल नोट और उससे नेक्स्ट फ्रीक्वेंसी हुआ है हायर नोट। ओके, जो हायर नोट है दे आर कॉल्ड ओवरटोन्स। And in case of closed organ pipe, we have seen only you can generate the odd multiple of fundamental. 1 time, 3 time, 5 time, 7 time, like this. Whereas in case of open organ pipe, you can have all frequency which will be generated by this fluid. 1 time, 2 time, 3 time, 4 time, 5 time the fundamental. All are available. Okay? So, the quality of sound produced by open organ pipe is better. आपको एग्जांपल लेके बताता हूँ। पहले लोग नमकीन खाते थे, स्नैक्स लेते थे ना, नमकीन क्या होता था, सिर्फ सेवियाँ या सिर्फ दाल। आज मिक्सर आने लग गया, उस स्नैक्स में नमकीन में सेवियाँ भी हैं, दाल भी है, मूंगफली भी है, काजू भी है, बादाम भी है फ्राई किए हुए। उसको लोग ज़्यादा पसंद करने लगे क्योंकि जिसको मूंगफली का टेस्ट है वहाँ से पिकअप कर ले, ठीक है ना। जिसको दाल खानी है दाल पकड़ ले, अपने पैंट जिस सेवी पकड़नी सेवी पकड़ ले, काजू पकड़े काजू पकड़े, किशमिश भी डालो कि वो पकड़ ले। सबकी चॉइस आ गई ना। तो सिर्फ दाल स्नैक्स में बोलो नहीं यार ये मुझे तो वो दाल ये नहीं अच्छी लगती, आलू भुजिया अच्छी लगती है ना, सेवियाँ दाल नहीं अच्छी लगती। लेकिन जब मिक्सर बना दिया तो एट ए टाइम सभी को सेटिस्फाई कर दिया। तो जो क्वालिटी ऑफ साउंड है दैट इज डिसाइडेड बाय द नंबर ऑफ हार्मोनिक्स प्रेजेंट इन द साउंड, नंबर ऑफ ओवरटोन। जिस साउंड में जितने ज़्यादा ओवरटोन होंगे उतनी क्वालिटी अच्छी होगी। अब इसमें तो सर्टन ओवरटोन्स आर मिसिंग, वन के बाद सीधा 3 टाइम फंडामेंटल आ गया, सेकंड टाइम तो है ही नहीं। तो इसलिए इसकी क्वालिटी बेटर मानी जाएगी, इसकी क्वालिटी क्योंकि इसमें सर्टन ओवरटोन्स आर मिसिंग। बट माय पॉइंट, द क्वालिटी ऑफ साउंड इज डिसाइडेड बाय द नंबर ऑफ ओवरटोन प्रेजेंट इन द साउंड। Okay, when you pronounce, let us say, you pronounce ka. When you say ka, ka is svar, इसमें स्वर मिला हुआ का। When you का उच्चारण करेंगे ना, जो साउंड पैदा होगी, it will not contain only one frequency, it will contain mixture of frequency. और का जो उच्चारण कोई करे और करे आपने बहुत बढ़िया उच्चारण किया है का मीन्स आपने क्वालिटी ऑफ साउंड अच्छी दी है, क्योंकि आपने जब उसका उच्चारण किया, जो साउंड जनरेट की उसमें ओवरटोन ज़्यादा थे। गॉट माय पॉइंट। अब इंग्लिश डिक्शनरी में यू हैव 5 वॉवल्स एंड अदर्स 21 दे आर कॉन्सोनेंट्स। कॉन्सोनेंट दे हैव देयर नो साउंड ऑफ themselves। दे टेक द हेल्प ऑफ वॉवल्स। ए बी में ई बैठा हुआ, डी सी में भी ई बैठा हुआ, ई वॉवल है, बिना ई के सी का उच्चारण नहीं होता। ओके, तो इसलिए बिना स्वरों के आप नहीं बोल सकते, उनकी अपनी आवाज़ नहीं है। तो सिर्फ हिंदी वर्णशाला में आपको 44 अक्षर है, उसमें 11 और 33 है, 11 स्वर है, 33 व्यंजन है। तो व्हेन यू प्रोनाउंस एनी सिंगल लेटर it will give you sound which is a mixture of many frequencies. Or quality of sound will be decided by how many overtones are there in the mixture of the sound. इसमें कई frequency, एक frequency नहीं कई हैं। आ भी बोला, ए भी बोला, जो sound generate हो इसमें कई frequency, एक नहीं है। Got my point? इसलिए quality of sound किसकी अच्छी होगी, इस sound के अंदर जो frequency में ओवरटोन ज़्यादा होंगे। तो आपने क्या देखा इधर, ऑर्गन पाइप ऑल overtones are present, 1 time, 2 time, 3 time, 4 time, 5 time, all frequencies are available. So therefore the quality of sound produced by this open organ pipe will be better than the quality of sound produced by closed organ pipe. ये ध्यान रखना।